We did classification of types of carbons yesterday to end class. We're going to start on classifying types of hydrogens. So types of hydrogens are determined by the type of carbon the hydrogen is bonded to. So a primary hydrogen is bonded to a primary carbon. So I'm going to go through that real quick. So primary hydrogen bonded, oops, that's almost a letter, bonded to a primary carbon. A secondary is bonded to a secondary carbon, right? And then a tertiary H is bonded, there we go, words, to a tertiary carbon. So we can't ever have a quaternary hydrogen because a quaternary carbon is bonded to 4 other carbons, and then that leaves no room for there to be a hydrogen on that molecule or on that carbon. So we only have primary, secondary, tertiary hydrogens. Good for me to flip. What type of carbon is that? Primary. That means all 3 hydrogens bonded to that carbon. These are all now primary H's because they're on a primary carbon. What type of H is that? Euler. Tertiary. There you go. Make it dated 80s movie reference. Someone will pipe up. That's fine. Type of H on this carbon. Someone said there was a quaternary hydrogen, which is not a thing. So I kind of explain why that's not correct in this next little bit of the video. There isn't one, right? Because this carbon is bonded to 4 other groups already. So there's no room for a hydrogen, so there's no H here. Sneaky. It's a quaternary carbon, 100% correct, but there's no hydrogen on it. So there's no H. So classifying hydrogens pretty easy. All right, cool. So we can have things on our molecules other than carbon and hydrogen. And when we start changing hydrogens for different atoms, we get different molecules that have different names and different properties. So we're going to start with some basics here of naming groups or molecules. So changing an H for a different atom. leads to different molecules with new properties. We'll actually make that a P. And names. All right, so I'm going to do 3 first, and then we'll do some more. So, right, so let's say we have this. Oh, real quick. How many carbons are in this molecule? 4. 1, 2, 3, 4. I know that it looks like this last bond, the one right here, right? It goes from the carbon to the hydrogen. So some people will sometimes get confused initially and think, well, that line ends and then there's an H. So that's a carbon with an H. You can't have an atom like a hydrogen just kind of floating by your molecule. You have to have a bond from your molecule to that atom. So even though like it doesn't go like right up and touch the H, that bond goes to that hydrogen. So there are only 4 carbons in this. But let's say we take off this hydrogen and we replace it with an OH. This will make an alcohol. Right? And that's a really squirrely line. Right, I still have 4 carbons. 1, 2, 3, 4. I can do the same thing. I can take this H. I can lose my H. And I can add, say, NH2. That will make this molecule now an amine. So alcohols, you removed an H and put on an OH. Amines, you removed an H and you put on a nitrogen, in this case an NH2. Right, the last thing here is going to be, so we have an H, we remove that H, and then we're going to add X. Now, X is any halide. This is our abbreviation for halides. So this would be an alkyl halide. Right, so you have, for example, so X is going to be fluorine, chlorine, bromine, or iodide. So just kind of like R is any carbon chain, X is any halogen. Right? So these 3 things, right? An alcohol, an amine, and an alkyl halide. These are functional groups. And functional groups are sites of reactivity in a molecule. So, like, just an alkane, something like butane, is not particularly reactive. Right? Carbon-carbon bonds are pretty strong. They don't want to react with other molecules. Carbon-hydrogen bonds are pretty strong and don't want to react. But we're able to do reactions at these things like carbon-oxygen bonds or carbon-nitrogen bonds. We're able to do reactions. Those bonds are more apt to react with other molecules. So functional groups give us effectively a handle to do reactions, for your molecules to do something. The carbon-hydrogen bonds aren't reactive. These other types of bonds are reactive, and they let the molecules do different things, right? So I'm going to give you a bunch of examples of functional groups that you 100% have to know. So every exam I've ever given has a section that's worth between 6 and 10 points where you just have to name functional groups that are on a molecule. And I've always said I will stop asking this question when everyone in the class gets them all right. It's been 10 years, it's never happened, right? Also doing this gives me an out for when you go to biochem and you take your first biochem quiz and Richardson comes to me and goes, they don't know their functional groups. And I'll be like, I asked them 8 times on exams. And so then he can go away. I won't get in trouble. Right? So functional groups. First, right, you have your halides or alkyl halides. Right? We have our alcohols. Right? So halide is, right, a carbon bonded to a halogen. A alcohol, you have a carbon and it's bonded to an OH, and it's going to be bonded to a carbon on either side of it. We have ethers, right? You have a carbon, you have an oxygen that is singly bonded, has one bond to a carbon on either side of it. We have ketones. So a ketone, you have a carbon that is double bonded. So it has 2 bonds to an oxygen. And then on either side of this blue carbon, you have a single bond to a carbon. Related to the ketone, we have the aldehyde. You've got a carbon double bonded to an oxygen, so it has 2 bonds to the oxygen. And then on either side of that carbon, on one side you have another carbon, and on the other side you have a hydrogen. Then we have carboxylic acid. Again, you have that carbon double bonded to an oxygen. One side you have a carbon, on the other side you have an OH. So carboxylic acid. We have esters. Right, you have a carbon double bonded to an oxygen. And then you have a carbon on one side of that carbon double bonded to the oxygen, and then you have an oxygen bonded to some carbon chain on the other side. So you have O effectively like R, because this can be any carbon chain out here. So one of the most common mistakes people will make when they are doing the functional groups is they will confuse ester and ether. Right? They'll just remember it's the E one and not the structure. So remember, ester is going to have a double bond. Ether has an oxygen that has 2 single bonds. So then if you have a nitrogen involved, right, that is an amine. if you have, we're going back to double bonds for a second. So if you have a carbon double bonded to an oxygen, carbon on one side, and a nitrogen on the other, you are going to have, this is going to be an amide, which I don't know why I'm in orange. Right, and then there are, I added a few that are, I'll have to throw up a new set of slides, but I added a few that aren't on your set of slides. The first being carbon triple bonded to a nitrogen. That most often is going to get written as C triple bond N, or I guess I should throw on here C, just abbreviated CN. This is a nitrile. Then I've got N double bond O, O minus, N plus. That's going to most often be written as NO2. And this is called a nitro group. Right, so now there's a few other functional groups that just contain carbons that I want to go over. So if you have a carbon double bonded to another carbon, this is called an alkene. If you have and that can be at the end of a chain or in the middle of a chain. Doesn't matter, both of these are alkenes. If you have a carbon triple bonded to another carbon, again, at the end of a chain or in the middle of a chain, this is an alkyne. And then the last one, we're just going to call aromatic for right now until we learn its real name in Organic 2. Right, so this whole ring, right, so a 6-membered ring with 3 double bonds in it, we're going to call this an aromatic. So I use the term double bond a lot during this video, and someone asked me to kind of clarify what a double bond is and give just a little more detail. Sure, so we'll get into like more of the structure of it in later on, but basically, so normally, right, this carbon here, this one right here, is making 4 bonds, right? It makes 1 bond to this carbon, 1 bond to this carbon, a bond to this hydrogen, and a bond to that hydrogen, right? So it's making 4 bonds, 1 bond to each individual atom. If you have a double bond, our orange carbon is still making 4 bonds, right? It's making 1 bond to this carbon, 1 bond to this carbon, but now has 2 bonds to this oxygen. So it's still making 4 total bonds, but it's making 2 bonds to a single atom, and that is a double bond. So what you should be able to do is, on an exam, I'm going to do something that looks like this. You can imagine that little do-to-do in your head as you're doing the problem. That's fine if that works for you. And there's going to be boxes. It's going to be like A, B, C, D. Right? And so I'm going to just be like, what is the functional group in box A? It is an ether. What is the functional group in box B? It is, in fact, a ketone. C? Amide. Yep. So organic chemists say amide Inorganic chemists say amide, and they're wrong. Just, you're better than that. And then what is in box D? Eight letters. It is an aldehyde. There was a lot of pressure there for me to have had the right number of letters for aldehyde. You don't know. It was rough. I was like, oh God, what if I screwed this up? Right. So on the exam, you're going to have a problem that looks almost exactly like that. And your job will be to do exactly what was just done and fill in the names of those functional groups. And you will get this question on every single exam. I should just be giving away an entire letter grade, right? Should be giving away 8 to 10 points every one of these questions. So if you know these, you are good. Now, for most of these functional groups, you are going to denote them in a name by using a suffix. You're going to put something after the parent hydrocarbon's name to denote whether or not that functional group is in the molecule. So the only two that don't get suffixes the only ones that we need to worry about now are halides and ethers. Right? Every other one of these functional groups that I gave you, there is a suffix that gets put on the parent hydrocarbon's name, and that is going to tell us that group's there. So I'm going to go over a bunch of rules on how you name functional groups, and they're going to be geared to the what are they called? The functional groups that get suffixes on the name. So rules for naming functional groups. And again, I'm going to specify that these are functional groups that get a suffix. All right. Rule number 1. The parent hydrocarbon is the longest chain that contains the functional group. So if there's a tie, go with the one that has the functional group in it. If it's a situation where maybe you have like a chain that's 8 carbons and a chain that's 7, but the 7 carbon chain has your functional group in it, congratulations, you have a heptane. Right? It just makes naming way easier if you make sure that your longest chain has your functional group. Right? When you have a suffix, right? Number to give the functional group the lowest possible number. So when you have a functional group that gives you a suffix on your name, your first job is to number it so that your functional group, that suffix has the lowest possible number. Even if it makes the other numbers in your name larger, the most important thing is that suffix getting the lowest possible number. So I'm going to do a lot more examples. I'm going to just tell you right now that the suffix for an alcohol is OL. So this is 5 carbons. So this is pentane. There's an alcohol, so it's OL, all. So it's pentane all. And there's a methyl group. Let's get rid remove this dash. You're going to number this way, so that makes the alcohol 2. Right? So you don't care about the substituent number. The alcohol is going to be 2. So it's going to be, oh, we didn't mean to switch pages there. 2, 4. Right? So you always number to give that suffix the lowest possible number. Right? This also ties into rule 3. Again, move that random number. If there is a functional group and a substituent, give the functional group the lowest number. What this does is on rings, you don't have to number a lone functional group. I should say for one functional group on a ring. The reason is that you know that you're always going to give your functional group the lowest possible number, and the lowest possible number on a ring is always 1, right? So the kind of the default is that you assume that if you have a functional group that gives a suffix on a ring, that functional group is going to be number 1, and then you do the rest of your numbers off of that functional group being the being number 1. So for example, say we had this, right? So this would be cyclohexane all. And I know because I have this functional group here that the carbon that functional group is on, that is carbon number 1. So now all my numbering is going to be done off of the fact that I set the carbon with the alcohol as number 1. So this will be 4 ethyl cyclohexanol. Right, number 4. If a functional group has the same number regardless of the direction you number, make sure the next substituent has the lowest possible number. Right, so for example, we can go back to a ring and show that on a ring. So let's go to a ring real quick, do a ring example. All right. So we know that we're going to be cyclohexane all, be ethyl, right? I have 2 ways I can number. Make this blue. I can number this direction and get 3 ethyl, or I can number this direction and get 5. Either way, my alcohol is going to be number 1. So I'm going to number in the blue direction because that gets me the lowest number for my next substituent. So this will be 3-ethyl cyclohexanol. We could also do this for, so you could also have something like this, let's say. right? So this would be, again, pentane all methyl, right? Do I want a number in the blue direction or the orange direction? It'd be orange, because if I go orange, I get 2, 3 for my alcohol. If I go blue, my alcohol is still 3, so I have the same lowest number, but now my methyl group is 4. So I'd rather number orange, because that gives my methyl group the lowest number, while also keeping that same low number for my alcohol. And again, you will never forget this, I promise. List your substituents. In alphabetical order. Right?
I gotta ask where Rule 5 was. Yikes.
This is my horrific squiggly 5. That is my step 5. That's fine. It's fine. I like that was just like secretly like, you can't draw numbers. I understand. I copped to that. All right. So the general structure of a name, right? You're going to have all your substituents are going to be to the left of the parent hydrocarbon, right? And then to the right of your parent hydrocarbon is going to be functional group suffixes, right? So everything over here, right, listed in alphabetical order, right? Over here, give the lowest number. Oops. Okay, apparently I'm not going to make that other. Fine. There you go. Give the lowest number. So the functional group suffix gets priority in in numbering to be the lowest, and then all your substituents get numbered. If there's no suffix, we just treat everything that we have on this left-hand side just like we would anything else. So, if there's an ether over there or a halide, they get treated like ethers and halides get treated like substituents. So they don't get any kind of special treatment. They're just the same as if they were an ethyl or a propyl. But alcohols and amines that get suffixes, they get the special treatment where they get the lowest possible number. So we're going to start going through how to name stuff. So what I like to do is, here initially, I'm going to teach you how to name a few things with suffixes. And then each time we start a new section that covers the reactivity of a functional group or group of functional groups, I'm going to teach you how to name that particular functional group. So we're going to be revisiting naming and the rules for naming all the way through Organic 1 and Organic 2. So you never get to really forget this stuff, because it's always going to come back every couple weeks. It's going to be, hey, now we have to know how to name ketones. Let's go over how you name ketones and kind of refresh yourself on the basic rules. All right. So the first thing we're going to do is we're going to do alkyl halides. Right. So here you have a halide or halogen in place of a hydrogen. Right. We categorize these the same as we categorize hydrogens, or classified like hydrogens. Right. A primary halide is on a primary carbon. A secondary halide is on a secondary carbon, and a tertiary halide is on a tertiary carbon. And just like hydrogens, I can't have a quaternary halide because there's no space on the carbon for that group. So the naming for these, right? So for naming, you remove the INE and add O. So what that means is, right, all the halogens end in INE. So, right, so it's bromine, that becomes bromo when it's on a molecule, when it is a substituent. Chlorine becomes chloro. Iodine becomes iodo. And fluorine becomes fluoro. But otherwise, these are pretty much... So, other than that, now we just treat them like they are substituents in our names. So they get no preferential treatment in terms of the naming rules because they don't have a suffix that goes on the parent hydrocarbon. So what's our longest chain here? Hexane. Yep. Right, and then what are my two substituents? Yep. So it's not bromine, it's bromo. It's not methane, it's methyl. So here's our longest chain. Right, so now do I want to number orange or do I want to number blue? Blue. So this will be 3 and 4. So no matter which direction I number, the two numbers I get are 3 and 4. Right? But now what we do is we say, well, whichever one comes first alphabetically, that's the one that's going to get the lowest number. So bromo comes first alphabetically, so it's going to be 3, 4. So 3 bromo, 4 methyl hexane.
So the question here was, do we just add O to the end of everything and call that good? Or is it just specifically the halogens?
Only when it is a halogen. So all the halogens go from like bromine to bromo. But other groups, like if it's an oxygen there, it gets a suffix. If it's an ether, then that gets named differently. The only one that goes INE to O are the halogens. So what would my longest chain here be? Heptane, correct. Very good, very good. Boop. Heptane. All right. What are my substituents? Yep. Methyl, oops, ugly H. Methyl, ethyl. And just like if I had two methyl groups, it would be dimethyl. Having two halogens, this is going to be Okay, again, we lack space. We're going to try to fix it here. It's going to be dichloro.
The question was, does the di impact where the substituent comes alphabetically in the name?
It does not. So, again, I think the best way to think of it is think about you've put all of your substituent names in first, right? So you're like chloro, ethyl, methyl, and then you go back and you say, well, how many chlorines do I have? Okay, I have 2, so I need to put a di there. How many ethyls do I have? So you've already put your substituent names where they go alphabetically. Then you go back and put the ditritetra in front of that. So they're already kind of locked in place. Do I want a number blue or orange? So remember, the chlorines, because they're on the left-hand side, they're listed on the left-hand side of the parent hydrocarbon, they're not special. They're just like any other substituent. So our number one goal when we number is to put the lowest possible number in our name. So if I go in the orange direction, the lowest number I get is 2. If I go blue, my lowest number is 3. So I'm going to prefer to number in the orange direction because that gives me the lowest single number in my name. So this will be 2, 3, 4, 5. So this will be 2-methyl, 3-ethyl, 5,5-dichloro. So 5,5-dichloro, 3-ethyl, 2-methyl heptane. Do one more for good measure. That's a little ugly. Yeah. Let me save it. There you go. All right, so what's my parent hydrocarbon here? Cycloheptane. And then what are my substituents? Yeah, 4-iodo. Tetra. Alright. So, where am I going to start numbering? Am I going to start numbering at carbon 1, 2, or 3? Which one's going to be the carbon I'm going to start numbering at? 1. Yeah. Plot twist. So this is going to be 4 in the end. So it's going to be 1, 1, 4, 4. So 2-butyl, 1, 1, 4, 4. Tetraiodo cycloheptane. So far, so good?
And that's going to be the end of this video and the end of this class. So I will catch you next time.